We've talked about translations that slide. We've talked about reflections that flip. And today we're going to focus on rotations. A rotation is a turn, which is circular movement or orbit of a figure about a point. So you can see right here, I've got some shapes. If I started with this blue triangle right here, each of those points is going to rotate. It's going to travel in an orbit around that center point if I rotate it right here. And so this pink triangle, this yellow triangle, this green triangle is various rotations of being through that center point right there, that corner of the triangle. So one thing that's important to know about rotations is that all rotations are assumed to be counterclockwise. Counterclockwise goes to the left against the hands of a clock. That's what it means, counterclockwise. So if it looks like this and it says rotate 90 degrees about the origin, that's what it would look like, lowercase r, 90 degrees about the origin, then it is assumed that it is counterclockwise. If I want you to rotate clockwise, counterclockwise is shorthanded like that. If I want you to rotate clockwise, or CW, I have to tell you. One way you can remember it is remember that in a quadrant, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we're going to go in the way that the quadrants are numbered originally in mathematics. Okay, so it says to use patty paper. So first we're going to talk about how it happens. One way to do this in a way you can do it with paper, okay? And then we're going to look at some rules, and I'll show you a little shortcut for how to notice the patterns of what's going on. So D originally started at 4, -2. We're back to our figure we have used so many times. E is at 7, 4, and F is at 8, -4. So that's the original coordinates. So I'm going to rotate 90 degrees counterclockwise. So let me show you what that's going to look like. I can do it with patty paper, just so you can always use patty paper if you want. But I'm going to line up an axis. You have to have a reference point. We're going to rotate it around the origin. I've already got D, E, and F marked on my paper. I'm going to rotate 90 degrees. You have to have this origin right here. You have to have that so that you know where 90 degrees is. So 90 degrees would be taking the x-axis and lining it up with the y-axis. So if I plot my pencil right here and I rotate it 90 degrees, and I line up my x-axis with my y-axis, it puts my new D right here, my new F right here, and my new E right here. Now let me show you. So that puts my new D at 2, 4. It puts my new E at -4, 7. And it puts my new F at 4, 8. Okay, and we'll talk about that pattern in just a second. Now I want to rotate it 180 degrees. So I start back over. Of course, you could just leave from where you were, but so you can see it. 180 degrees. So X, there's 90 degrees. And then we're going to go another 90 degrees. So we line it up right here. So now my new D, if I rotate 180 degrees, my new D is -4, 2. My new E is -7, -4. And my F is -8, +4. And then if we go 270 degrees, it's just another 90 degrees. So let's rotate it just one more time, 90 degrees. That puts me right here. That puts my D at -2, -4. It puts my E at 4, -7. And it puts my F at -4, +8. And you can see, right? I mean, so all those numbers, I had just pre-counted it already. If you trust me, right? I can see -2, -4, right? F is at -4 and -4, -8. So 1, 2, 3, yeah, 270. And then E should be at 4, -7, right? So, sorry, I had my key wrong. So these are where they are. I rotated it with patty paper. You can always use that with pad paper, okay? You can always do it. You just have to be sure that you are clear, that you mark it neatly, that you mark your letters, and you keep up with it. So it does have its own hindrances too. All right, so now let's look at the pattern. Notice that all of my numbers are the same, okay? Notice that every 90 degrees, D started in quadrant 4, right? So I just want you to see this. D started in quadrant 4. At 90 degrees, it jumped to quadrant 1. At 180 degrees, it jumped to quadrant 2. If it rotated 270 degrees, then it rotated to quadrant 3. So notice that every 90 degrees, it jumps one quadrant away. So D went from 4, -2 to 2, 4 to -4, 2 to -2, -4. So notice what it did. Notice, look at that square. See it jump perpendicular to itself every time. So notice that the numbers are trading places every 90 degrees. And then notice that our signs match the quadrant that we came out of. Let's do the same thing with E. So let's notice E here started in quadrant 1. Okay, then it jumped 90 degrees and it ended up in quadrant 2. When it jumped 180 degrees, we went from quadrant 1, 90 degrees, 180 degrees, so we ended up in quadrant 3. Notice the signs match quadrant 3. And then when we jumped 270 degrees, we started in quadrant 1, 90, 180, 270. We ended up in quadrant 4. Now, mainly why I'm getting you to see this is I want you to see this pattern that we're going to use and also the pattern about the rules. Notice that your numbers are switching places. It's still 7 and 4, but the only thing that's different is the sign values. But I'm trying to show you that the sign values come from the quadrant that it's going to land in. That'll help you to remember the rules or to remember the trick. Okay, notice F did the same as D. It started in quadrant 4, and then every 90 degrees, it would jump another quadrant. Okay, so here are the rules. These are the things that if you want to memorize the rules, this is a good place to do it. So if you are going to rotate 90 degrees, then you're going to start, your value is going to start with XY. And then what's going to happen is it's going to become, right? So you're going to rotate 90 degrees. So you're going to go from quadrant 1, because everything in your rules assumes that it starts in quadrant 1, okay? So we're assuming that we're starting in quadrant 1. That's the trick with the rules that you have to remember. So 180 degrees, or excuse me, 90 degrees, you're going from quadrant 1, and you're going to go to quadrant 2. Notice when I went from quadrant 1 to quadrant 2, my numbers traded places. So my X and my Y are going to trade places, similar to when I reflected across Y is equal to X. But this is a little bit different because when I go from quadrant 1 to quadrant 2, when I'm in quadrant 2, my X position, right? This is my X position, but now I'm putting my Y value. There's a difference, right? The value of Y goes right here in the spot that's X. It becomes negative positive, right? So this is negative positive. So you're going to have a negative Y and a positive X, okay? If you go 180 degrees, then notice what happens, right? We started 180 degrees. Notice that your 7 stayed in the same place, your 4 stayed in the same place, but it became the opposite value. So because it happened this, it started in quadrant 1, it jumped 90, 180, and it landed in quadrant 3 where all of the signs are negative. So your XY becomes, it stays X, it stays Y, but everything is the opposite of what it was before. Okay, and then 270 degrees, we start in quadrant 1, so XY starts like this, and it jumps 90, 180, 270. Now it lands in quadrant 4. Notice what happens when we did that. When we landed in quadrant 4, notice that our values were different, right? They were switched. So we're going to switch our values. We're going to have our Y where our X was and vice versa. But this time we're in quadrant 4. In quadrant 4, everything is positive, negative. So you're going to keep positive and you're going to be negative. So this is one thing. You can just remember that whatever your values are, they become switched and opposite. So you can memorize these rules. If you are a rule person and a good memorizer, then that would be something that's good. So what you would need to notice though, is a way to memorize the rules, or the pattern for the rules is this, is that notice that every 90 degrees you're switching places. So we are going to switch, or we're going to be the same as they were originally. So it's going to be XY or YX, XY, YX. So your numbers are going to switch, or they're going to be in the same place for every 90 degrees. So every 90 degrees of rotation, it's going to be switch, same, switch, right? So switch at 90, same at 180, switch at 270. So every time you jump, you say switch, then you say same, then you say switch. If you wanted to go around multiple times, 540 degrees, then you would switch, same, switch, same, switch, same, and you keep going until you hit 540 degrees. So we're going to switch and same, and then we're going to get our position from our sign. Okay, we're going to take the sign of whatever of quadrant 1, 2, 3, or 4, wherever we land. Okay, so notice what's going to happen if you start in quadrant 1 and you rotate 90 degrees, they're going to switch and they take on the sign of quadrant 2. If you rotate 180 degrees and you start in quadrant 1, then they're going to take on the signs. So it would be switch, same, and you're going to take on the signs of quadrant 3 because you landed in quadrant 3. And then if you start in quadrant 1 and you switch, same, switch, you end up in quadrant 4 where the signs are positive, negative, and so you're going to take on those signs. So I always like to switch, same, sign. Those are the things they're going to say, switch, same, sign. It's just a quick trick to help you land in. So we'll show you how this works because I think that the rules are the easiest rather than using the graph, but you may certainly use whichever is the easiest for you. So if we look at number 1, endpoints FG are at -2, 4, and 3, 1. Okay, so I'm going to write my pre-image over here so I can see what's happening. -2, 4, and G is at 3, 1. There's my pre-image. So you can see it if you want to. -2, 4. There's my original F, and there's my G is at 3, 1. Sometimes I think it helps to see it on a graph so you can see where it ended up. So using the patterns. So if you want to use the rule, remember X, Y to rotate 90 degrees. You're going to switch your values, right? And then 180 degrees. And then 270 degrees. If you want to use the rules, here's how you do it. Okay, so just memorize that pattern right there. So if you want to do that, totally fine. So look what happens. So this is 90, this is 180, this is 270. So let me show you both ways. Okay, so F, let's do 90 degrees. So this means I'm going to switch them. So I'm going to get the Y value and I'm going to change the sign. It was positive, now it's negative. And I'm going to leave X the same. That's how you use the rules. And if you do G, then I'm going to switch it. I'm going to take the Y value and I'm going to make it the opposite, -1, and I'm going to keep X the same. And that's what it looks like. Now on paper, here's what it would look like. You would be at -2, 4, so you go back -4, -2. There's your F prime. And G will be at 1, 3, so it will be right here. There's your G prime. So there you can see what it actually looks like if I rotate it around the origin. That's your original blue line, and then you rotated it and you get your pink line. And you can kind of see, right? If I take this paper and I rotate it 90 degrees, doesn't it look like that pink line? Now, let's do it with switch, same, switch, right? So 180 degrees, and this is where you want the graph so you can keep up with what quadrant you're in. So you can do F. So F, 180 degrees, you're going to go switch, same, okay? So switch, same. We end up in quadrant 4 with our same numbers. So you want to just look at the numbers. So you're going to keep your number, the value of the number, the 2 and the 4, and you're going to take on the signs of quadrant 4, which is positive, negative. Okay, let's look at the same with G. Switch, same. Keep them in the same order, 3, 1, but give them the signs of quadrant 3 where they landed. So either memorize these. You're going to have to memorize these, or you're going to have to memorize the trick, right? Switch, same switch. One of the two, but you're going to have to know how to do one of those. 270 degrees. I'll do one of each. So if you want to use the rule, 270 degrees says to switch them, right? So your first number, you're going to use the y value, which was 4, and you're going to leave it alone. And you're going to take the x value, whatever it was, and you're going to make it be the opposite. It was -2. Now it's going to be +2. Okay, so 270 degrees, right? Switch, and then so let's do G. Switch, same, switch. So G started here, switch, same, switch. So it's going to land in quadrant 4. They're going to be switched, so it's going to be 1 and 3, and it's going to take on the signs of quadrant 4, which would be 1, -3. Okay, so it's switch, same switch for 270, it's switch, same for 180, and it's switch for 90 if you want to use the rule. What would you do if you wanted to rotate 90 degrees clockwise? Well, 90 degrees clockwise looks like this. Well, that's the same as 270 degrees counterclockwise. So you would do the same rule, switch, same switch. Or you can switch them and take on the signs of quadrant 4. So if you wanted to rotate from quadrant 1 into quadrant 4, then you switch the numbers, they trade places, and then you take on the signs of quadrant 4. It's whatever sign you land up, whatever quadrant you land in. Okay? Now, notice this one's a little bit different. It has the signs. Okay, so here's your rule. Now, like this one, I gave you the rule. All you have to do is follow the rule. So if you look, xy becomes y -x. So your x and your y are going to trade places, and whatever your x value is going to become the opposite of what it was. So my r value is at 3, 3. So my x value becomes my y value. So my x value, my x position becomes my y, which was 3, and my y position becomes the opposite of x, which was -3. I just followed the rules right here. It gave you the rules. So in this case, you didn't even have to memorize it. So S was at 8, 3. So your x value becomes your y value, which was 3, and your y value becomes the opposite of x, which is -8. Now, how many degrees of rotation? Okay, well, let's finish this out first. T, so T is at 5, -3. X becomes y. So x becomes the same as what it was before, y, -3, and y becomes -x, -5. And then u was 2, okay, so x becomes y, so your x position becomes y, whatever it was, and your y position becomes -x, the opposite of x, which was -2. Now notice, just so you can kind of see how many degrees, let's go here because it's easier. I went from quadrant 1 and I ended up in quadrant 4, right? Positive, negative. I ended up in quadrant 4. So if I started, and I go counterclockwise, always counterclockwise unless I say otherwise, right? Started in 1, I ended in 4. So 1, 2, 3, 90, 180, 270. So this is a 270 degree rotation. And I just followed the rules. That's all I did was follow the rules. Okay? So let's look at this rule. X becomes -x and y becomes -y. So we go back to our original. X becomes the opposite of x, which was 3. So now it's -3, and y becomes the opposite of 3. Okay, so notice it went from quadrant 1 to quadrant 3, right? So quadrant 1 to quadrant 3 looks like this from here to here. That's 90, 180. So this is a 180 degree rotation. Okay, S goes from 8, 3, so it stays the same, but it changes sign, so -8, -3. T goes -5, +3, becomes the opposite of what it was before, that's what it says. And then U becomes -2, +1, opposite of what it was before. Okay? Now, there's one other thing that you can do that's a little bit tricky, and that's if you're rotating. What if you don't rotate around the origin? What if you rotate around something else? So let me show you what that looks like. So L is at 2, 1. N is at 4, 2. and M is at 6, -2. And what I want to do is I want to rotate around N. Now, really, quite honestly, easy way to do this is patty paper, okay? So let me show you how to do it with patty paper, and then I'll show you another way to do it, kind of as a backup plan if you don't like patty paper. So you need to mark L, you need to mark N, and you need to mark M. You need to mark them accurately and cleanly. Now, what you want to do is you need a frame of reference. We are rotating around N. So my frame of reference is right here at N. That's how I know if I have rotated 90 degrees, is I have to put my plus right there so I know how much to rotate. So it says to rotate L, I want to rotate 90 degrees about N. I want to rotate triangle LMN around 90 degrees about point N. So what that means is that your pen is going to sit right here at N, and you're going to rotate 90 degrees. So you're going to take that x-axis and you're going to rotate it up. And that's where all your new points go, right there. So, and you name it according to the original axis. So that means L is at 7, 0, and M is at 8, 4, and N stayed where it was at 4, 2. It didn't move because that's the one you rotated around. And if you wanted to go 180 degrees, you could, and 270 degrees. And it's just easier to do it. Now let me show you the alternative. Okay, the alternative, I'll just do one of them this way. The alternative is let's relocate the origin. So here's my new origin. So based on my new origin, this is an alternative. If you liked that other way and you want to use patty paper, I will keep it available for you. Okay, so let's take L. L was right here. Now, L on the new axis, right, with a new origin, its new name is -2, -3, right? Its new name is -2, -3. So see, now we're rotating around the origin, right? Remember when you rotate 90 degrees, you go one quadrant around, you switch the numbers and you give them, switch same, right? You give them the same coordinate, or you give them the signs that you get from the coordinate. So we did switch or same, so we did switch for 90 degrees. We moved into quadrant 4, the new quadrant 4 right here, right? And we're ignoring the rest of it. We're just using the red one. We're now in the new quadrant 4 where everything is positive, negative. Okay, so now it's positive, negative. We relocate it 1, 2, 3, 1, 2 based on my red origin, my new origin. But then when I give my final answer, I name it based off the original 7, 0. So you can see that's time consuming, but it is a way that works and you might like it better. Relocate your origin, pretend like everything is on, pretend like the old origin isn't there and you're just working with your new origin. Rename it all, do your rules or switch, same switch with keeping the signs of the quadrant it came out of. And then when you get to the end, go, oh yeah, but I wasn't on that. I'm going to go back and name it according to my actual original black and white coordinate axes. Okay, so real quick, we'll go back. The rules, remember that we found out just the pattern is that every time it changes. So at 90 degrees, they become the opposite. At 180 degrees, they're the same order. At 270 degrees, they've switched again, and they take on the quadrant that they land in, assuming with the rules that you leave from quadrant 1, land in quadrant 2. Leave from quadrant 1, land in quadrant 3. Leave from quadrant 1, land in quadrant 4. The easy way to do it is to recognize the pattern that they're going to switch every 90 degrees, and then you're going to land in, you're going to take the signs of whatever quadrant you land in.